Here's a fact that I won't prove. The general solution to an m by m homogeneous system is an m-dimensional vector space. And of course here I'm talking about, I didn't put out the full name, but I'm talking about these recurrence relations I've been talking about. So if you think about what that means, combined with the superposition property I just talked about, it actually means quite a lot. So I'm talking about this type of recurrence relation here. A is a matrix, and it's a square matrix with m rows and m columns. And so what this is telling us is that the general solution, f of n, this is just going to be a linear combination of m different particular solutions, f1n all the way through fmn. So what that means is if you want to find the general solution, all you have to do is find m different particular solutions and then just take the linear combination of those, and that gives you the general solution. So in other words, each of these has like, you could make like a fundamental set of solutions which just contained m different solutions that were all linearly independent, and then all you have to do to find the general solution is you just look at the linear combination or the span of that entire set. Okay, so now let's look back at, well, first let me just say, the goal here is to try to figure out how to solve this type of equation in general. So before, like the video before last, I looked back at this type of equation here, which I've shown a lot of different ways to solve. And I showed how we can actually convert this to a matrix equation, a 2x2 system. And this is what the 2x2 system looks like. Here Gn just represents Fn plus 1. So we could solve this, and the reason that we could solve this is because we knew where it was starting from. We know how to solve this thing, and so we could find the solution. The solution to this thing is just going to be C1 times lambda 1 to the n plus C2 times lambda 2 to the n, assuming no repeated roots. That's kind of a big thing here. And then to find Gn, well, you just iterate it once, and then you find that this is just going to end up being multiplied by lambda 1, and here it's going to be multiplied by lambda 2. So if you want to see the full process, watch the first video in the playlist for systems of equations. But this is actually kind of useful if we're trying to solve the general m by m homogeneous system, this one here. So this is not what the general solution is going to look like necessarily. This was assuming that we started with this kind of second order equation here, and that's not always the case, as I also explained in that first video. If you start here, you can always get it into a system, but if you start with a system, you can't always get it into this form. So this is what the solution looks like if we had started out with a second degree linear recurrence relation. And then of course the other assumption was that it didn't have a repeated root. Of course we could go back and consider that, but it would be a separate case. You have to do this on a case-by-case basis. So anyway, but what this does do is it lets us see kind of more or less, well, we could make a guess of what the solution in general to one of these things would be. A very general guess. What we can see here is because of the superposition property, and because we know that the solution is just a linear combination of linearly independent pieces, we can see that this is one solution and this is the other solution. And so the general solution we got was just a linear combination of those. So we can kind of take this as a model, and we can use this to model a guess for the solution to the general equation. So this is what the generalized equation looks like, at least in the 2×2 case. We just have any coefficients here, a, b, c, and d, whereas here they're kind of locked down. And so of course this can also be written fn plus 1 is equal to a times fn. And what we can do is we can just take this, use this as a model for our guess, also known as an Ansatz. We can just say that our guess can just be that f of n is just going to be some vector filled with constants multiplied by some number lambda to the n. So one thing that happens here when we make this guess is that before we had meaning for these things for lambda, we knew how to solve it. Here we know how to find lambda because we know that that's just a root to the characteristic equation. But if we're looking at the generalized case, we're saying that there's not necessarily a second order equation like this that f of n satisfies. So we no longer have any meaning for lambda. We're going to have to figure out what the meaning for lambda is in the general case. We also have no idea what this vector v represents, and here it's even kind of hard to say what this represents. Aside from, we just know that gn is just the iterated version of fn, so that's, we can see where these lambdas come from. But so in order to solve this, we're going to have to, if we use this as a guess, we're going to have to figure out what's v and what's lambda. And so that'll be in the next video.